Mr. Tyson Tuttle, welcome.
I'm between you and lunch, so thank you very much for hosting me here in Shenzhen. I've been traveling to China for about 20 years now, and we have an office here in Nanshan and to support customers in South China, also in Shenzhen. And it's wonderful to be able to visit and to share with you some of our vision around IoT, in particular software, and how that is going to help enable the rollout of these technologies into the variety of applications that it represents. Silicon Labs is a 21-year-old company now. We've been publicly traded in the US since about the year 2000. And we are focused on silicon, software, and solutions for a smarter, more connected world, with the main focus of the company really around IoT and building the platforms for both hardware and software for that. We're serving a broad range of customers. We've got about 35,000 customers now, with our revenue approaching $1 billion and about 1,500 employees worldwide. So, we're very happy to be focused on growth markets and seeing the results of that, and really seeing also the proliferation of applications and our business globally. So we do a lot of business here in China, and it's a great pleasure to be able to sit here and to stand up and talk to everyone. If you really look at we live in a more connected world. And you've got, it's really today mostly an internet of people. We've got, first we connected mainframes, and then we connected computers, and then we've all got our smartphones. And that was really, things getting connected to the internet, but they were things that were attached to people. And so there was a user interface, and people were interacting with that. If you really look at how the Internet of Things is different, you've got, really, these are machine-to-machine type of devices. They're collecting data or actuating and controlling. And so you've got, there's not a user interface. You also look at the fact that IoT, the devices in IoT are addressing a really broad range of applications. Everything from smart cities to smart factories to smart homes. And there's lots of different, thousands of different applications of IoT technologies. We saw, examples of that earlier today. And then you also look at, if you're going to be deploying billions and billions of these devices, into lots of different things, they have a different set of constraints. And so these are really the three different things. Machine to machine, you look at the fact that you're constrained by cost, by power, by physical size. And there's a lot of different constraints around IoT which are different than you would see in a PC or in a handset. And we're going to talk about put some numbers to that as well. And then you've got, of course, the broad range of applications. All right, so if you look at a connected device, it's really a combination of hardware and software. And actually, it's really, if you look at the software, is really what defines the personality of what this is. We heard before about, from Xilinx about the fact that all the different devices, you can't have one platform or one chip that's specific to an application. And really, a lot of the personality as you address the variety of applications is really in the software. And so if you look at connected devices, you've got a lot of different software that's required. You've got protocol stacks. You've got a lot of middleware and different things to run those protocol stacks. You've got connections to the cloud. You've got to interface with the sensors, and you've got to be able to deal with security. A lot of different things. And once a device gets connected, it's got a life, right? You've got to commission it onto the network. You've got to provide updates to the software and updates to the functionality, and ultimately decommission the device at the end of its lifetime. So there's a lot of different things, and a lot of that is defined by the software and the architecture that's around that, not just the hardware. I wanted to talk a little, we talked about the thousands of applications. There's a few examples which I think are really, instructive to, what these things are doing. The one on the left is Broodminder, which is really around agriculture, one of the very important application areas for IoT. And this is where these are monitoring beehives. And they developed a platform of, I think they have about 10,000 connected beehives monitoring temperature and humidity and activity and various things. And really looking, all those are connected to the cloud, and they're looking at all of the data, doing analytics, and trying to understand, hey, you should go check this hive, you should go check that one, there's something weird is going on. And that can have, bees are what make, all of our food grow. And so that's a really important application. Just one example. And, being able to give farmers and different people information and things that they can take action on that help improve yields, to improve outcomes in agriculture. The middle is Singled, one of our customers here in China, doing smart home, doing lighting, smart lighting. And you start looking at, it's not just a light bulb that you turn on a light, but you can have predictive analytics. You can do AI type of things. So, oh, I'm coming home, turn on the lights, it's the morning, change the color, and integrate them with other things within the smart home. So the smart home is a very, very important application area, and one that, variety of different applications, tons of different customers working in this area, and a lot of activity going on here in China as well. On the right, this is an example of a skateboard, but you have, we talked about cars earlier here today, and cars are certainly being connected. We have proliferation of scooters and bicycles, it seems, in a lot of different parts of the world, and the smart skateboard, but being able to, change the billing model, to change the business model, to change, do monitoring, and, improve the outcomes of transportation and help us get around and also make traffic more efficient. A lot of different things on the transportation side. So these are just a few of the many applications of IoT technologies where you've really got connectivity, you've got processing, you've got the cloud, you've got a lot of security, a lot of different things have to come together to make customers successful in these areas. So you really look at all of those different applications, all the different industries where IoT technology is really changing the industries, changing lives in a lot of different ways. And this is by 2025, the economic impact to the world. The global GDP is about $100 trillion. And it's predicted that IoT technologies, the hardware, the software, the services, the deployment of these across the various industries that will happen over the next number of years will have a $10 trillion per year impact. This is a 10% improvement in the productivity of the global economy. And it represents a huge opportunity for companies to deploy these technologies. So our customers and people that are using IoT technologies will, by 2025, be realizing $1 trillion worth of revenue from those technologies to be able to deploy them out into the world and to provide services and to make that economic impact, to make transportation better, to make homes safer, to make industries more efficient. And if you really look at the opportunity for hardware companies like ours, Silicon Labs, the silicon, the software, the solutions that we're able to deliver, a lot of them wirelessly connected. You're not going to have that many wires. They're going to be battery powered. You have a lot of constraints, but $100 billion worth of content and that represents a very large opportunity. Just for reference, the semiconductor industry this year will be about $450 billion. So it would represent about 20–25% of today's semiconductor industry just in the IoT area, all the different things that you're able to deliver from that. So this is a big opportunity for technology companies, for semiconductor companies, for software companies, and for general industry and lots of different things going out into the economy, and it's going to have a very large impact. This year, we'll have about 10 billion connected devices sold. And this represents the $10 billion this year. This includes PCs and handsets. So in the communications area, this is the handset area. And then you've got computing. But you've also got a lot of industrial applications and a lot of consumer applications. And you look at the growth of that here through 2025, where we're going to have 23 billion units, and you've still got about 4 billion handsets. There's a lot of stuff in the cloud and in tablets and in PCs, but you have huge growth in industrial, huge growth in consumer. And so the growth in the number of devices, and this is in billions of devices per year, so going from about 10 billion devices to 23, with really the growth in things outside of those people-connected devices. These are mostly machine-to-machine. And then you've got this automotive piece, 1.6, that could be your scooters, that could be your bicycles and cars. And we talked about, even though this on a unit basis is small, represents a big opportunity as well down here on the transportation and automotive side. So there's a huge explosion of devices that are going to be shipped, and it requires a lot of engineering and a lot of software to get there. And IoT is not just about selling devices, it's really about creating new business models around really ecosystems and a collection of devices that are then connected to themselves, connected to the cloud, that can, it's not just purchasing the device, there may be subscription models. There may be ways to participate in the savings that are being generated from the deployment of these technologies, whether it be liability, whether it be improvement in supply chains, and that can generate recurring revenue. So it's not just about the deployment of things once and it's done. It creates value over a period of time, and that helps to create different ways in businesses that we can all participate in. So we talked a little bit earlier about the fact that IoT is different, and that it's really got constraints in terms of power and in terms of cost and memory and footprint and all of that sort of stuff. So I wanted to kind of put that into perspective. If you're talking about the data center, we learned earlier today about going from 1,000 watts to 140 watts, but you're talking about a lot of power in a car or in a server. And these are mostly powered by AC, or you have huge batteries connected to them or something like that, and they're going to cost a lot of money. Okay, so this is the cloud. You look at PCs, notebooks, laptops, that sort of thing. You've got maybe 100 watts, 100 watt-hour battery in that, and that battery may last for a day, right? You have to charge your computer. It may last for 6 hours or 8 hours or something like that. But it's on the order of 100 watts. You might have a terabyte of storage, if you're lucky, as opposed to petabytes here in the cloud. But the price point there, maybe $1,000, about 7,000 RMB. And now the handset, this is it's something that fits in your pocket. It might have a 10 watt-hour battery. Again, it's only going to last for a day, but it might only be consuming at the peak 10 watts of power, and you might have a gigabyte of storage on that, or gigabytes, hundreds of gigabytes of storage, and it might cost $100. For IoT type devices, now you're talking about something that not just has to last for one day. This has to last for 10 years or more, and it might have a coin cell battery, which is only 1 watt-hour. In size, so a very small amount of energy, but it has to be useful. It has to do some real stuff. It may only be able to cost $10 at the store, or to be, for each device to be deployed. So you've got constraints on the amount of memory, the amount of processing, and all of that. So there's a lot. It's very different from the technologies that are deployed into these other areas, and it requires a different level of optimization of both the hardware and the software to be successful and to be able to hit those targets. If you look at the wireless connectivity in a mobile phone, you've got a lot of different technologies: Bluetooth, Wi-Fi, positioning information, LTE, 5G coming, and these have all evolved separately. If you look inside of the phone, it's maybe 20 chips inside there: separate memory, flash memory, RAM. You've got an applications processor, you've got power management, you've got all of the connectivity, you've got RF and front ends, and it's a lot of components, and that leads to that $100 cost that's there. So these have been optimized for specific technologies, each one of these functions, and have remained separate. over many generations, over 10, 20 years of development. If you look at IoT applications, we really sat down and said, well, these all need to be integrated onto a single chip. If you're going to hit those constraints, if you're going to hit the cost, if you're going to hit the power consumption, you really have to optimize all of this together. And you have to integrate the wireless connectivity with that and put that into what we've called an IoT SoC. And we set off to build that. And today we have a portfolio of, and a platform-based approach for the EFR32, the wireless Gecko platform that can serve this broad range of applications, support multiple protocols, works at very, very low power levels, and can achieve that 10-year battery life on a coin cell while still delivering very good functionality at the cost points that are required for the market. Looking at this a little bit more detail, and I won't go through this completely, but again, you have an ARM CPU, you've got memory, you've got interfaces, and a lot of the peripherals that you would expect from a microcontroller type architecture. You have integrated radios, multi-protocol, multi-band radios. You've got power management, very important security, a lot of evolution going on there, and a lot of able to go to sleep, but still do some useful functions during that time. We call this the peripheral reflex system, and a lot of the clock management and stuff that's going on there. And you've got a variety of flash and memory options depending on the functionality that you're trying to achieve, what application you're going after. So this is the hardware. But we talked about the fact that the hardware is not really, it's just a chip. Now you've got to do something with it, and you've got to get it into all of these different applications. So it's really the software that's going to decide the future of the IoT. You know, you look in the servers, you know, Intel did the hardware, you had Linux and Microsoft doing the software, and the PCs, Intel, Microsoft, again, you know, Qualcomm, Android, ARM over on the handset side. So that really those hardware and software platforms evolved separately. And they could, because the hardware wasn't really that constrained. It had to be very, very general purpose, and had a lot of power available to it. And the software became a platform. If you look, you know, really, the software has to be, you know, for very high volume applications, has to be very customizable. You've got a few customers, you know, if you're Alibaba or Xiaomi or some of these different companies that are you know, building very high volume applications and have very high levels of engineering bandwidth, they will customize that functionality a lot. A lot of applications serving the long tail, you know, tens of thousands of customers, want something that just works, wants it to be simple, wants it to be easy. And really this whole concept of simplicity, making very difficult things accessible and easy to use is actually very difficult. And so, you know, going to different types, you know, instead of writing, you know, full C code, maybe going to a command API. Maybe it just powers up and works, and it's already preloaded with software, and it just connects to the cloud. There's a lot of different models there to enable the long tail, and that's what's really important about making IoT a success. So really, when you talk about IoT, it's our belief that the hardware and software has to be co-designed, particularly the embedded software, but also the way it interfaces to the cloud, the way security is done. You know, we talked about the constraints in storage, power, you know, the battery life required, the cost, and that, you know, really you've got to be able to provide the hardware and the software together and optimize them to be able to achieve the maximum functionality for that amount of energy that you have and for that cost point that you're able to achieve. So this is the hardware and software platform that we offer today. We talked about the IoT SoC with microcontrollers, flash, all the different peripherals, you know, doing key storage, doing all the security. But then you've got to have modules to make it easy to use for customers. You've got to have development boards and a lot of ways for customers to be able to interface and interact with it. But this is just the hardware. You know, then you've got to have the platform software, all the different components. And you don't necessarily want everyone to have to be experts in all of the all of the software. But that all has to be there, and it has to be capable and proven and updatable, and work across this entire portfolio of parts and across this variety of applications. You've got to have connectivity software. You've got to also be an expert in connectivity, in Wi-Fi and Bluetooth and Thread and Zigbee and Z-Wave. And a lot of customers, a lot of industrial customers may have legacy devices that they have to be compatible with. They may have a stack that they have to run, and there's a variety of ones here. And you've got to abstract that, and then you've got to maintain that and make sure that it's best in class and adapt to the new standards. You've got to be experts in connectivity, not just in the hardware, but in the protocol stacks, the interoperability, the certification, the compliance to the standards of those. And that's a huge investment. And it's really a lot of software required for that, not just the radio piece. Just because you have a radio doesn't mean that you can actually communicate reliably for the next 10 years. So you've got a lot of other things when it comes to being able to make connectivity work and make that kind of bulletproof for the customers. And then you've got to have tools. You've got to be able to make all of those tools that the customers can use, whether they want to dig down in and get into every last feature that's available, or something that they just need to get this hooked up, they need to get it to work, and they need to get it to market as quickly as possible. And so, everything, we call it our Simplicity Studio, but building apps, looking at how much power is being used, what types of tool chains you're going to use, and then all of the different application notes and documentation and example applications and really being able to support. That's one of the biggest challenges of IoT. When you have tens of thousands of customers, you've got to figure out how to get them to market quickly and as simple as possible, both for our own sake, but also to make customers successful across what we talked about, thousands of different applications for IoT. So this is our Gecko hardware and software platform. And we've been on our first generation, working on our second generations with cycles of learning going into this, where you've got connectivity, you've got the software, hardware platforms all coming together. So when you start putting this together, we're talking about the IoT devices that connect up. And they connect up to gateways, they connect to the mobile handset, they connect to the cloud. You've got going to the gateway for the local area networks, Wi-Fi, Z-Wave, Zigbee, Bluetooth, a lot of different technologies going there. Typically, the mobile handset is talking to the internet with Wi-Fi or with an LTE, 5G technology coming soon. And we've got the narrowband technologies coming to the IoT devices, particularly the ones that are going to be mobile. But then you've also got a lot of functionality in the cloud. You've got connections to the web, you've got connections to applications and analytics. And then you've got to be able to maintain all of the devices. Sometimes you're going to be having functionality within the gateway to make all of these technologies work seamlessly together. So all the different devices, no matter what they connect to, are able to talk to one another and be functional. And if your internet connection is broken, you may have functionality that's here. So connectivity and intelligence and processing at the edge, that's also a very important piece of making all of this work together seamlessly. And that's true whether it's in a home, whether it's in a factory, whether it's in a city. You've got to distribute a lot of the intelligence, from the cloud all the way down to the end. And a lot of these devices have to get more intelligent as well. You've got cameras, we talked a little bit earlier, one of the speakers talked about AI and machine learning, even at the end node level. And if you think about having to do that at those cost points and at those power levels, it's a big technical challenge. And so we have a lot of work to do, but it's a lot of opportunity sitting in front of us as well. All right, so I'll conclude with this. We talked about the fact that it's not just about the hardware. It's also about the software that unlocks the potential of, and the value of what's going all the way from the chip all the way up to the cloud. And, that impacts the entire value chain and life cycle of what we're deploying in the IoT. And there will be many, many companies that are doing hardware products, doing software products, building ecosystem, building platforms globally, both here in China, in Europe, in the US, and they need an integrated hardware and software platform at the edge, at the end node, that helps to make that possible. And we believe that we're leaders in the development of that area. And it's very exciting, all the different, both the business growth as well as the proliferation of applications that we see out in the market today globally. And to make that possible, the integration of the hardware and software, and to be able to go and not have to piece that together and not have to pull it from different places, but to go and get all of that in one place. And it doesn't mean that we have to do every piece ourselves, but we have to make it all work. You want to have an open platform, you want to have standards, you want to make sure that that scales into the future, but it has to all be curated and maintained not just for today, but for that 10 years or 20 years sort of lifetime. And I think that it's also very important to collaborate, both with industry alliances. We talked about standards, we talked about ecosystems, and really to be able to provide that technology and those platforms and make it accessible to as many people as possible through collaboration and through open dialogue and helping to make each other successful. I think that will benefit all of us, will benefit the entire industry. So if we look, there's a lot of, I could have filled this slide with names of companies, both here in China and globally, that we work with that need to collaborate. And these are just really the ecosystems that we're talking about. You've also got device makers, you've got semiconductor companies. And it's, as we talked about before, the opportunity is huge in terms of the economic impact, the value of the services that we're providing, as well as the hardware and software that we're all building together. So I appreciate your attention. Thank you very much. And hopefully maybe if we have any questions, we'll have time later in the afternoon to take all of those as well. So thank you very much.